the method editor from the point of view of some advanced features. So, as mentioned a number of times, the method editor is oriented toward MRM. And if we drop down into the advanced tasks, we have talked a bit about the other scan modes and creating quantitation methods for those extracted signals. A couple of things I'd like to point out in passing I may have forgotten to mention. One is that in the qualifier setup, you do have the capability of area summing. So this means that you can take not only the target signal, but you can also sum the qualifier signal with it. And you'll notice a slight change here in the qualifier ratio. That may be useful if you're trying hard to get a stronger signal. In addition, there is the global setup in the method. So the global setup presents a couple of options here in terms of configuration. We have apply the multiplier to the target, apply the multiplier to the surrogate. Now, the multiplier is basically the dilution factor. So in the sample row, you have a column called dilution. If you dilute your samples, that multiplier would be applied appropriately to the final concentration. So the quantitation engine calculates the calculated concentration, and the multiplier affects the final concentration. That's the typical usage of the multiplier. The multiplier also can be affecting the ISTD. In normal situations, the ISTD concentration is the same across all the samples, but if, perchance, it has not ended up that way for you, you potentially can adjust the multiplier to affect the ISTD concentration. The reference windows are the same as the single quad quantitation engine. The reference window applied to the target and the non-reference applied to the ISTD are used to figure out if that peak belongs. And what I'd suggest here is to keep the defaults here for the triple as they work. The correlation window involves the relationship of the time that the qualifier comes out in relationship to the time that the target comes out. And again, I'd leave this as the default value. There has been a discussion in another section about using the ignore peaks not found to strip out peaks not found messages. I'd like to show you a feature which is useful when you have larger methods. In this case, the first two compounds are in time segment 1, and the other compounds in this method are in time segment 2. So imagine that I had a lot of compounds and I had divided them up into time segments to do my MRM quantitation. What I can do here is I can group by time segment. Now, grouping by time segment just gives me a different visualization where the hierarchy now has changed so that I can see the compounds in time segment 1 together, and I can see the compounds that are in time segment 2. So I can explode the hierarchy and drill down with that grouping. That can be very useful. Let me also mention in passing that in analysis, in batch at a glance, once I've applied this method that has multiple time segments, I can also navigate by time segment there as well. Let's take a look at the advanced tasks. And we'll go directly to mass extraction setup. So, the mass extraction setup, I can see that for each compound and its qualifier, I have visibility into the left and the right setting for the mass extraction window. So if I look over here at amphetamine and look at the product ion, I'll see that if I subtract 0.3 from the left and then add 0.7 to the right, I will have the mass extraction window for this particular signal. It's a little bit lopsided to the right, and that's because of the molecular mass and its tendency with carbon-based compounds to be a bit more than the elemental number. Now imagine that instead of these defaults, you are actually quantitating a signal from a time-of-flight instrument. It might be useful to tighten up on these signals, and you could create a smaller extraction window here by tightening up on the left and the right, which would allow you to extract out a finer portion of the signal, which would be applicable in a time-of-flight situation. We have talked about the integration parameters setup previously in the Integrator Advanced section, but I would like to point out that with the integrator comes filtering. So I'm using the MSMS integrator, and one trick that potentially could remove very low-level integrated signals is to filter that by peak area counts. So if I've decided that I don't want to see anything less than 100 counts for that particular compound, I could set that peak filtering, and then there would be no integration because those peaks would not appear on the peak list for the integrator to integrate. Next on the advanced topics, I'd like to take a look at isotopic dilution setup. Now this is in the advanced tasks again, and you'll notice for the compound, I have columns asking me for Rx and Ry. Now, you will, I think, ask what are Rx and Ry, and I will refer you to an article written by Colby, and these are called Colby constants, which describe the relationships between the isotopes and the isotope dilution adjustment that happens to take care of naturally occurring isotopes in standards. So I invite you to read this paper to get a full understanding of the Colby constants, but it can come in useful. Last in the advanced tasks, I'd like to show you the browse acquisition method. Now, for the particular sample that you came across with the method editor, if it occurs that you want to know more information that is in the quantitation method, and by the way, the quantitation method does have access to columns such as the collision energy and the fragmenter, but there are pieces of information that are not brought across into the quantitation method. Let me show you the acquisition method. Now this is a grid that is bound directly to the acquisition method, which is stored as an XML document. So there's a bit of understanding here to this organization. There are time segments, of course. There's source parameters, as you can see here. As I move through this document, it will start to seem a bit more familiar because the organization of the MRM acquisition method is by scan segment, and here I've got the compound cocaine, and I've got unit resolution, I've got the transition there. And if I go over here, I can actually see the dwell time and the fragmenter and collision energy that were used for that particular compound. So, you can use this as a quick reference once you see the organization, the hierarchy of the acquisition method. Otherwise, you can go back to the acquisition application to check and load your acquisition method there. This is basically a quick reference in the quantitation to check something if you want to understand how that sample was acquired. All right, thank you for your attention.